下面有请来自 Deutsche Telekom 的高级云技术专家 Daniel Gaaf 先生，他的主题是 Ceph 的邮件存储技术，大家欢迎。Let's welcome Deutsche Telekom Senior Cloud Technologist Mr. Daniel Gaaf. He will bring us his speech. Email storage with Ceph. Okay, Mr. Dan.
Yeah, hello. My name is Daniel Gaaf. I'm working for Deutsche Telekom. Deutsche Telekom is the biggest telecommunication provider in Germany and a big one in Europe. So, and I speak today how we work on storage for email. So we have an existing platform that we want that we use for that. So there is a customer platform where we provide email services to our customers. That is backed in the back end with Gaaf, an open source solution for that. And currently we're running it on traditional network attached storage. So it's NFS based and it's heavily sharded to make it work at all. And we have currently on the system 39 million accounts from the customers. That makes round about 1.3 petabyte of storage for emails in real. And that makes something around 6.7 billion emails in the system. And it's growing, fast growing. The reason is why it's fast growing is that we had till some months or years ago the policy to delete mails after 90 days, and now we have unlimited storage, so it's growing faster. And besides that, the mail system itself needs something around 1.2 billion cache and metadata files to make it work. And the system provides around about 32% of usable storage. So the rest is for replication and so on. If you take a look on NFS operations, you will very easily see that there are a lot of operations that are metadata operations you don't really need, but they are there and you have to handle them. And so a lot of that is metadata operations. Only something around these two blocks here, something around 20% are really I/O, writes and reads, as you can see on the NFS traffic at the end. So the pain is still that you have to optimize your system for the whole I/Os. And as you can see, we have in maximum times with high load, we have something around 800,000 IOPS in total, but only 160,000, 170,000 IOPS are really traffic that is relevant for us. So, and that's the same as if you take a look on average load. What would you guess is the size of an email usually?
50 kilobytes.
What?
50 kilobytes.
Yeah, you have seen it already. So normally you would expect it's lower, right? But our customers obviously get a lot of HTML mails and whatever. It's not these are most likely not developer accounts. So if I get an email from a mailing list, it's probably much smaller. We have in this system even emails that are 600 megabyte large. Don't ask how they get in there. They didn't come through the mail system. They came probably via IMAP. So how are emails stored? Usually they're only written once because they are not changed. And read many is relative. I mean, how often do you read your email? It's probably once, and second time maybe, and then it's it. It's stored in a mail tier or mailbox. Everybody knows that from his own machine. And the usage for the storage in our system highly depends on what the customer is doing. So it's different for different protocols, and it's different if it's a protocol or it's the webmail system. So it produces different load. And usually the metadata is stored on a different place. But that's very critical fast. If the metadata is lost, you lose your mailboxes. You can recover in mailbox, but you don't know if the your user created any directories, if he read an email, if he forwarded an email. So for the customer, it's not really fun to get in this situation. And yes, without any attachment, it's very easy to compress. So what is our motivation to do something different? So for sure, we want to have faster automatic self-healing. Currently, in a NAS system with RAID underneath, can get fast very critical. We want to have less I/O overhead. We want to get rid of the metadata operations. Sure, we want to get out of our window lock-in we currently have. We want to use commodity hardware, not some black boxes from a vendor. And the idea was to have open source where feasible, because the mail system is already open source. And sure, as always, operations want to reduce costs. So if you take a look on Ceph, I don't need to explain this one, right? So you will see it very often these days. Where could we store emails? One would be to use Cephalocon, right? So, but at the end, it's the same as NFS. It's still POSIX compliant. The mail system will do the same. You have the same I/O overhead. So the POSIX layer is adding the same complexity as before. So for emails, from our point of view, it's not an option. But you can easily use it for metadata, caches and indexes. That's probably a case. Security-wise, it requires direct access to the storage network, right? So that's something you probably don't want to do in your cloud, depending on your security requirements. I can't do that. I can only do it in a dedicated platform. So the alternative would be probably to use RBD, but that needs sharding or very large RBDs, which is a little bit complicated. And at the end, you always reach a point where you have to migrate accounts, or to have the RBD extended, or the file system on the RBD extended. And at the end, it also includes, again, on the RBD, an POSIX file system, and it doesn't change anything. And sharing between clients from the mail system is not that easy, and it's impractical. Security-wise, it would be the best solution, because there's a virtualization layer in between that's great, and you need no network access to that. So the other option would be, I mean, an email is an object, right? So why not using object store? So Routers Gateway, you can easily store it as an object in Routers Gateway, but it needs additional network hops, probably. It needs a load balancer, very likely. You heard the problematics that SAP had in this area, and it's potentially a bottleneck. And from our point of view, it's very likely not fast enough for this use case. Security-wise, it's comparable at the end to what you have with an RBD. You have no direct access to the storage network of the cluster, and it can easily be secured by a web application firewall. There's a third option, that's routers itself, right? So you can also use librouters to store an object. It gives you direct access to routers and allows you highly parallel I/O. It's an advantage, but it's not optimized yet for email. I mean, writing an email application against routers would be not that much fun. And the question here is how to handle metadata information and caches and indexes. That is a little bit complicated. And security-wise, it's the same as you have with Cephalocon. You need direct access to the storage network. Therefore, you can only do it in our case, in a dedicated platform. So that's a limitation. But it's no issue because the platform is already only a dedicated system. If you take a look on the combination out of the mail system we have, the mail software we use, the open source software, and Ceph. Dovecot is the mail system, as I said, we use for that, and it's open source, LGPL. It has a very large market share in the mail system that's based on open source solutions, and it's growing. It's very large. It already has a plugin for Object Store, but it only supports S3 or Swift, and it's not open source. That's the so-called enterprise feature. I don't know, from my feeling, this model is dead. To have open source software and have an enterprise feature you have to pay for, and that's closed source. So it requires at the end a pro license, and that is paid per account. And there is, due to policies from the company providing the support, no discount on number of accounts. So you pay probably the same if you get 10 accounts, and we have to pay the same per account as you get 39 million accounts. So there's a large intake on the cost, right? And it's complicated. It's very complicated to set up. A lot of caches in between, and not easy to handle. So we did something else. So we decided there is no open source solution currently on the market for our mail system. Closed source wasn't an option. So we decided, after a long discussion with the company, to do it on our own. So we developed its own solution, was sponsored, and open source it for sure. So we partnered with Guido de Hollander for the development and consulting, and we have a company called Talents, which is already maintaining our mail system for us, so they do development for us, and we selected Suzy for the Ceph part. So we wrote a Ceph plugin for Dovecoat, and in the first step we selected a hybrid approach. That means we put the emails in Rados directly and put the metadata on Cephalocon. So we have 2 clusters for that to handle it. And the idea is to have a very generic email abstraction. It's not specific abstraction for Dovecoat. It's so generic that you also can use it in any other mail system very easily. And as soon as the first release comes out, we split up the code. The part that is Dovecoat specific, the plugin to Dovecoat goes to Dovecoat, and the rest goes back to the Ceph community. That is how it currently looks like. So we have, as I said, 2 clusters, but we have still local caches. That's something you don't get away, because the clients in front that gets the mail before it's stored to the storage, that needs local cache. It wouldn't work otherwise. So the project is called librmb, stands for lib Rados mailbox. There are parts of the email that, as I said before, that don't change ever. And this part is stored in Rados, so we don't need to rewrite anything. But we have a bunch of information on an email, like when did it arrive, some UIDs for the mail system, sizing information, and so on. That's going actually in Rados extended attributes. And everything that we really need to change goes in the metadata information of Dovecoat and go into Cephalocon. So that is basically what you get. We wrote a small little tool to get the information out of Rados that is reflecting at how an email looks like. And not, you could get the same information directly with Rados command, but it's basically written to make it easier for the administration. And we also wrote an dictionary plugin to use the OMAP key value store. And the idea behind that is that we later, in the second step, want to get rid of Cephalocon. We want to use the OMAP for metadata information and the caching and so on. So it's open source, as I said. It's also under LGPL. It's written in C++, and it's already available on GitHub. So, and we support several Dovecoat versions. It's basically because our mail system is not running on the latest version of Dovecoat. So there are different trees, and we will support all of them. But I have to remark, it's still under development. It's not completely finished. So if you want to use it in production, I would say don't. And there are packages already for, obviously for Suzy available for that. So first we thought, what Ceph release should we use? What features do we have? So we have, for sure we need Blue Store. Performance-wise, we need it, and it should be in many use cases faster than File Store, right? For Cephalocon we also have some requirements. We need a stable release, sure, and we need multi-MDS support and certificate pinning, we expect, to make it work. And for cost reduction, we need erasure coding to keep the costs low, because an email system is nothing you make money with. It's a giveaway, a free giveaway to our customers. Yeah, and we need the usual requirements that every operation has, right? So we use Luminous for that, and the fitting product from Suzy for that. So SAS5 and /5 SP3. On the hardware side, we use very commodity hardware from HPE. Standard hardware. It's actually, we ordered 9, but now getting 10 generation dual socket machine. And each machine has 2 times 10G, 4 times 10G, 2 times dual port 10G for the network, so 40G in total. Bandwidth is not really the problem, it's always I/O on email systems. So we have some SSDs for boot, and we only have, as recommended, only in HDD and no array controller in there. We have 2 types of nodes we run there. So one type of node is for the MDS, and the OSD is basically the same. So it's cores, the CPU has 6 cores, 2 times at the end, and a lot of RAM. And for the OSDs, we have their 8 times 1.6 terabyte SSDs to store the SSDs for the OSDs for Ceph explicitly. So, and we have some different, so we call them routers nodes because we store the mails there and directly in routers. The CPUs here, we have more cores and lower frequency for the cores and less RAM, but it's basically the same. We put there 4 terabyte spinning disks in, standard SAS disks, nothing special. We selected relatively small disks because we want to have a better distribution on smaller I/O, right? So, yeah, you probably asked why that specific hardware. If you take a look on the community recommendation, which is, from my point of view, not really up to date, but that's much different to what we currently have. So probably NUMA is an overkill, or high clock CPUs are probably an overkill from the cost side using, and large RAM probably also. But first of all, it's for the first installation, and better have it there than be sorry later, right? And the point is that HPE doesn't offer any single core machines for the storage type of storage, so that was no option to have non-NUMA machines. And besides that, you must know that an MDS performance is mostly CPU clock bound because it's partly single threaded, and that's a problem. So you want to have high clock CPUs. Single thread performance mostly hangs with high performance on this CPU, right? So, and always, yeah, more RAM is always better for caching, so it's not a cost point. So how do we place it? So we have in general some issues in our data centers, and I'm sure many of you also have. We have usually only 2 independent file compartments in each data center. So, and maybe some additional virtual file compartment, meaning somewhere is a room where you can co-locate something. It's not the same availability as the rest, but it's there. Yeah, but how do you place 3 copies, right, in 2 file compartments? That's a little bit tricky. And sure, the requirements are the requirements you always have. Every rack can fail, a file compartment must be failing, every switch should fail and should produce any problems, and even, yeah, the file compartment can fail. So that's the tricky part with 3 copies. So what we actually do is, the green nodes are the nodes we use for routers, and since we there use basically erasure coding, I don't have the copy problem with 2 copies, right? And for Ceph we use replication and put them in the co-location room. Since even in the final sizing, we only need 15 SSD nodes, and that's easy to place somewhere. So the problem of the 3 missing room, or the room that has not the same availability, is not that big. So we have a classical network, classical spine leaf architecture with bonding and everything. So we terminate L2 traffic directly in the rack, and the rest is L3, and it's very classic system, multiple switches per rack and so on. So what's the status actually? So we are through with the first testing phase. So we had very small clusters for functional testing to check if the mail system is really working. We did it already, and it's run all IMAP-based tests the suite provides. We fixed some issues on the way, so it's now working, but now we are testing against our own installation, which is a little bit different from what you normally do with upstream. So we have to do everything again, and it's in progress, but it looks good. So, and from the hardware side, we have a build code, we have a POC cluster test built, and it's running since this month, which has 9 SSD nodes for Ceph and 12 HDD nodes. That's basically what I showed on the picture before. So, and we put it in the, as I showed, in the virtual file compartment, 1 copy, and are doing now their testing in the direction of load. That's the critical part, and especially failure scenarios. So we have to really make sure that the erasure coding is the right one, and the settings are the right one, and the performance is fitting, and that nothing goes lost, because per law it's not that easy to make a copy of an email and do a backup, especially with European privacy laws currently. So it's the case that if the user deletes an email, I also would have to make sure that it's instantly also deleted in the backup, and that is something that is tricky. So that's the reason why we don't do backups on emails. So if we lose customer data, then it gets ugly very fast. Yeah, and for sure we need to prove and tune the Ceph setup. We are on that. I actually don't have numbers yet. I can present, but very soon, I guess. And probably we also very optimize the hardware, because it's probably overkill and we can reduce it a little bit. So we have some topics we need to solve, and didn't solve yet. So erasure coding is one. So especially the fact which erasure coding are you using. So we need to run performance tests, and especially what kind of profile we run there. And we need to optimize it somehow for relatively small writes, right? I mean, even 50K is a small write for erasure coding. Compression is one topic we would like to use. We are currently not sure, because we don't currently split off the attachments, so it can be complicated, but we could easily compress everything that has no attachment. And we want to use BlueStore inline compression for that, and it's already, that's the part that's not accurate, it's already implemented in libRMB. And the next thing we want to work is, if we can make it work with OMAP for storing our 1.2 billion files we currently have, or the information of these files we currently have in the index metadata files. So that is something we would like to move to OMAP, because we would like to have only one technology. We don't really want to use Cephalocon. If I can avoid it, I would like to avoid it. Yeah, cluster bandwidth is a topic we currently discuss, especially not for the clients, but for the backend. So we need to see how fast we can recover a cluster that is 70% full, and then it's probably something we need to tune or add more network bandwidth there. And one topic we have, and it's a real problem, there is, at least not on the free market, there is no load generator for email. So that's a little bit tricky to produce a real-life test for that. But we discussed already with CERN, and they are also interested on the topic, so we probably come there up with a solution, a separate project for load generation or for email traffic. Yeah, so the next step is we move it to production. As soon as we have it finished. Sure, we need to fulfill all our requirements, but I'm confident that we will make it. The integration and production is very easy. It's not a very difficult task from the mail system side, because you can migrate users step by step, and you don't need to do it on your own. You can simply say, the mail system, there's another storage, move this user to the next storage. So the mail system is doing that on its own, so it's simply a new backend, as if you had a new net app staying around and you're moving customers there. So that's something that's very easy from our side. So where do we get? So what we are planning currently is to get something around 5 petabyte for that in the first step. That is what we need to reflect what we currently have. That makes 1,200 OSDs in the current setup if we don't get bigger drives, but I guess due to performance for small writes we don't want to. And as I said before, it's the 9 SSD nodes we currently have is nearly what we need, but we need 15, it's not that much. So if we are confident to remove this part of Ceph, we probably integrate them into the HTTP nodes to use them for something else. And that's the plan where we want to go, as I said before. So we will still have local storage for caching in the client machines, but we only want to have for emails and for indexes one solution, and that's Rados. And that's where we're working for. So what conclusion can I make? We are very confident that it can replace NFS for emails. Because we will save a lot of I/O. We probably don't get to the point where we only have the I/O we need. It will be a little bit more. There is an overhead. But we are sure that we can save at least half or 75% of the I/O currently in this area. And that makes it a lot cheaper than the current solution. The mails go in Rados. Currently they still go the metadata to Ceph. We will use BlueStore. We will probably also test those file store only to get numbers, but we aim for BlueStore and for erasure coding. And regarding the software we wrote, which is available online, it's open source. There's the plugin for the mail system, and there's the library that abstracted very generic way how to handle an email in Ceph. And as I said before, it can also be used in non-low-code systems. You could take any mail system and integrate it very easily. If the mail system is as a plugin system, right? I mean, if you need to change the complete code, that's probably more difficult. It's still under development. As I said before, I really say it here, it's on tape. Don't use it in production right now. Use it for testing. Don't move users there. And we are currently in the POC phase to make it really, really stable. So I would like to invite everybody that is running mail systems and probably interested on moving them to Ceph, participate. Or I also can say participate in the Ceph community, right? I mean, every commit is welcome, every documentation fix, every help is welcome. So contribute, report, bring bugs to us, and we will work on it. Thank you.